Alrighty. Looks like we are, generally speaking, ready to start another day of work. What joy. This is going to be my split keyboard project. Schizo notes, please do something. Which lecture is this for? Also, let me see what my settings are, because I might turn on ultra low latency for my stream. I don't know where the setting is to do that, though. Advanced? Where are the stream broadcast settings? Stack heap diagram? Okay, sure. We can learn together. Stream, YouTube, server, video, accessibility. What is it called? OBS ultra low latency. In your platform's stream settings, and or set up a 1 second stream delay in OBS advanced settings. Hi Janine. I'm trying to figure out how to turn on ultra low latency on OBS. I might have to stop streaming and then start it up again to figure it out. Encoder setting. No, it's not that. Yeah, I have no clue. Huh, okay. Well, I think for now it's fine. Let's see. Let me know when you send it, Alex. Oh, it looks like you did. Oh wow, those are schizo notes. What is going on there? Wow, okay. Point A, if V. Are there lecture recordings on here? Alright, let's pull this up on the stream. Why is this so low quality? Hello? Can I open? Yeah, open in browser. There we go. Okay. I can read it, but I would not get this from nothing. Lectures are not recorded. Okay, let's try to decode what they mean by this. Alright, so int main, file open, number something, So that's supposed to be a number text file. Insta fail, by the way. Can't drop. All right, let's lock in then. So first of all, what is stack and what is heap? Do you understand? So what do you know about the stack and heap so far? Heap long-term but slow, stack short-term but can only reach hop down. Yes. And yeah. So from what I understand, the heap is basically stuff that you want stored permanently. That's referenceable by basically everything in your program. Although if in C++ and stuff like that, like it also depends because you can have private and public and stuff, all that jazz. I don't really understand that. But in C at least, the stack is supposed to be for example, declared functions over here, int sum equals 0, return sum. That would be a variable that's on the stack. And the reason why that would be on the stack is because it's within the context of this compute sum function. It can live in here and die in here because ultimately we return int as a result of this, right? Same thing over here, double average, return average, lives and dies inside here. So on the heap, on the other hand, for example, this file.open, this returns a pointer to an allocated memory within the actual heap that stores the pointer for this number text file, whatever is going on inside here, right? This is 10, 20, 30, 40, right? So int sum is equal to compute sum v. So what that does is that it creates a sum, because once again, this is declared in main inside with this int call. Int sum is equal to compute sum v. So that gets created on the stack within the main part. Then when compute sum is called, there's another sum that gets created inside here. So that's what this is going on over here. Because what happens is we add 10, 20, 30, 40. So we get 70 plus 30 is going to be 100. So this is that little block right here. And then once we return this sum, that goes back to main, right? And so the compute average then takes in the argument of sum, which exists in main now. And then it wants to put the average in another stack variable. So this average stack variable now is going to be the return value of this compute average function. Now the compute average function is going to have this average variable. It's going to have this int sum. It's also going to have this, what is point A? If v.size, what is vector int v, compute sum, vector int v, vector int file open number, open. Okay, so it looks like vector int v is going to be another thing in your main stack. But then the file is actually a pointer to this heap allocated. Point A is where to draw the diagram up until. Oh, gotcha. Okay, that makes sense then, right? Because the reason why they stop allocating the stuff in average is because we've declared average, double average, but we haven't actually done anything with it, right? So we don't know what's inside the actual memory that's allocated in the stack for average. The thing is when you have average in here, what is going on here? If v.size is equal to 0, then average is equal to 0.0. It's supposed to be the pointer to the heap size capacity. Is that even a 0? I get 99% of the drawing, but why is the vector v in main vector pointer 0, 4? Vector. Or oh, vector pointer 0, 4. Let's see. What does a vector get allocated as? Std vector. Std vector has empty vector of size 0 with a capacity of 4. So I would understand that 4... Well, okay. Because maybe this 4 is just the capacity, right? But then the question is, what is this 0? I guess he just forgot to change the 0 to a 4, yeah. And the reason for that is because you see here in this compute average, the vector that gets passed into compute average. Oh, yeah. I think that makes sense. Because in compute average, he does it correctly, where this goes to here in the pointer, and then there's 4, then there's 4. Right. Yeah, I mean, the random circling and shit is just what happens when you talk through it. And then draw it. But I think what he means is that ultimately you go through this thing and you return sum, and that's the thing that gets output here. And the reason why you don't see a compute sum stack, you gotta know how to do this shit by hand. I mean, that's not terribly difficult. Like, I would practice just doing this with a couple, like, example C++ programs. Like, some really simple stuff. Like, stuff like this, right? I think the easiest way to do is just, for example, just look up, like, something on LeetCode. Just, like, super easy questions. Oh, write code on paper? That's kind of cooked. No Copilot? Yeah, I mean, surely the functions aren't actually going to be terribly difficult if you have to know. It's probably going to be stuff that's like relatively simple. Maybe there's some solace in that. I don't know. Alrighty. But does that sort of make sense? At least for a stack heap. I'd really just practice this. Like, just take a sample function, either one that you create or something that you can find online, and then just go through it and do the diagram yourself, because it's going to help a lot. Skim the thing I just sent, pages 5 through 7, to see what you have to do by hand. Sorted data class. Implement class sorted data is defined by sorted data.h. You must implement as given. Commenting is not required. You may assume the proper include statements using directed statements, provided you can't use the other feature of C++. Question 5. Oh, page 5 of the PDF. Wait, do you have to do this by hand? Because this is kind of cooked, no? C++ program that inputs integers from two files and outputs whether the files contain the same values. Two files left and right. Files contain the same values. Assume the existence of a sorted data class that inputs and source data from one file. Here's a class declaration. True if input failed, false if not. NT, brother. Yeah. I don't remember 211 being this hard when I took it. Yeah, I mean, if it's going to be, for example, like I would just literally study like how to input a file, how to know if it input correctly or if it opened correctly, that sort of stuff. Sorting, size, operator, what else is there? You can't use auto. You can use all the include stuff. Like I would just practice doing that sort of things that you know that they're probably going to ask. The file header? Yeah. It's been a bit long since I've done this. This is kind of cooked for me. Do you need to memorize stdioh? I mean, it says that, oh, you must provide all include statements in using directives. That's insane. That's crazy. Well, good luck. Well, part of it is probably they're going to be more lenient with partial credit, right? I mean, surely. One would imagine. Yeah, good luck. Let me know if you need some help studying. Your best bet is to probably just try to program things from memory, if you can, in the same vibe that the exam wants you to do it in, that your homeworks have been making you do it in, you know? That's how I would prepare for that exam. But at the same time, I'm really bad at studying, so don't necessarily take my words as what to do. Okay, anyways. I think now I'll probably switch gears and go to working on the split keyboard. Cool. So, we left off yesterday, I think, talking about what we wanted to do today. And I have it pulled up here, agenda for next stream. Nail down the layout, get library components in Altium for all the PCB parts, get Zephyr toolchain setup, schematic, potentially. And then I still need to place the order for the dev kits and stuff so I can do software development and testing. Either way, I think the most important thing that determines the rest of what I want to do with the keyboard is going to be the keyboard layout. So I'm going to pull a keyboard layout editor. This thing is one of the nicest, best keyboard tools in existence, by the way. If you just want to play around and make your own little layouts, it's the most fun thing to do. Alright, so should I do 1, 2, 3, 4, 5, 6 with a thumb cluster? Is this going to be the play? And then how many keys do I want? 4 should be fine, I think. And then what I can do is just take these and then columnar stagger them. 3, down 1. This one will be down 2. This makes no sense. What am I doing? This should be down. This should be up. This should also be down because this is both the pinky. And then this should be like that. Does this look about right? Maybe I should do this a little lower. Let me look up common keyboard columnar stagger layouts. Okay, because they just do ASDF G. Okay, so middle is going to be on D. ASDF ASDF G. Okay. So if I just do this, that looks about right, doesn't it? This might be a little aggressive in terms of the stagger, but nothing that shouldn't be terribly uncomfortable. I actually think this makes a lot of sense right now. So let's move that up. And you can just copy and paste this as well. Oops, let's do that. Can I mirror this? Is there a thing to mirror this? I think what I can do is just do this up, then do this down, and that's about the same thing, right? Yeah, that is. Cool. Now what do I want to do for the thumb clusters? Because this is the part that gets kind of interesting. This is where all of the designs are a little different. ASDFG. And then also, do I want to have function keys or do I want those to be included in the thumb cluster? That's going to be an interesting debate, I guess. Is comfortable. I wonder if I should like try printing this out or something and then seeing if I can increase the width just to play around with it a bit. What happened to it? What the hell? Oh, that's what happened to it. Okay. I could just copy one of the designs that are already on here. Seems to be a pretty common design to have. Yeah, okay. 0, no, what am I doing? 1. Secondary height is used as stepped keys. Okay, let's do 2 for this then. And just move this up here. Should I move it up here? How do they do it? Rotated. I don't know if I can afford doing a rotated. Okay, maybe I should just make my own layout and just see what happens. Because I don't like typing on 1U, so I could do 1.25, that would be fine. 0.25. Okay. I wonder if I just like put my hand on here and just see where it naturally lines up, if that would help. Wait, this actually is tech. Hold up. We might be onto something. I low-key want to shift the pinky row down one more. Makes it look a little weird, but I think that's what feels natural for me. Control Alt. Do I want a super? I could. The question is how many keys are in this selection? Summary. Total right now. Let's delete this, highlight these, bring these over. I could just have this here as well. Like this could just be another pinky modifier key. The pinky is doing a lot of work though. There's gotta be a better way of going about this. I wonder if this is of any benefit. Let me blow up the screen again, put my hand on here and just see how it feels. That might be a bit too large. Okay, low-key, that actually doesn't feel terrible. This would be interesting, actually. We might be onto something. Onto something or on something? What are we thinking? Hi, Ben. What do you think about this keyboard layout? Looks like any other split keyboard to you. Alright, that's pretty good then. Yeah. I don't know, most of them tend to use like rotated keys at the bottom, which is like kind of valid. But at the same time, I'm not completely certain if I want to go that route. I really want to just like print this out and then see if it feels comfortable. Like just like holding my hand on here. Just resting my like hand a little bit on the monitor screen, which is what I'm trying to do right now. Like it doesn't feel terrible. So I think the pinky keys are a little bit out of reach though. I mean, really, how many pinky keys do I need? Like what I could do is just boom, boom. Would this help? Not really, actually. It doesn't feel that much different. Okay, I think we're good with this then. I think we're good. And then what I can do is go to summary. What's the overall size of this thing? Keyboard plate generator. KeyBO plate generator. Keyboard layout editor, raw data, boom, boom. I like this one a bit better. Cherry. Case type, none. Draw my CAD. Okay, so the width is 266 millimeters. Height is 128. Oh, so it's a little bit tall. The thing is like, if I... JLC PCB. I can go over here and just get a quote. 4-layer board, 100 by 100. It's like $7. Yeah, $7. But if I go over here, well, let's see. $266. I'll just say it's 129 by 129. Let's see how much extra it is. $3.30. Yeah, it's not terrible. Oh, but this is for a 2-layer board. Zam! 3250. Alright. That's actually a pretty significant amount. Maybe I go for something that's a little bit smaller then. How do I reduce the size? The thing is, we could just go back to this design. And we could also convert all of these to just 1U, which is a little painful, but it is what it is. And let's just get rid of this. Raw data, Soul Keyboard, CAD details, BAM, draw. 114 by 109, so we're still a little bit off. What I'm thinking of right now is just getting rid of... Oh, this is going to be painful to type on then. But if I get rid of these, right? And just turn it into tiny keyboard. This would definitely be less than 100, I think. Look at this thing. That's crazy. CAD details, go over here, draw my CAD. Yeah, 95 by 90. And I don't know if we can make this any taller. I guess we can maybe bring it down by like 0.25 VU. Actually, what if I just increase the height? Like, this already looks more legit, but the question is if it still fits within the size. Let's see, draw my CAD. 100, barely. Okay, this would work. This would actually work. All right. I think we can just go with this layout then, and this is going to be really cheap and wouldn't be terribly uncomfortable to type on, really. Hold on, let me yeah, I'm thinking this feels a bit better. All right, should we go with this? Yeah, let's go with this. How many keys are there on this singular side? Summary, 19 keys in total. Oh, we can easily hook that up to every single GPIO pin that we need then. This actually is kind of interesting because I think we might actually just be able to get away with a 100 by 100 2-layer board if we only need 19 GPIO pins. Which, why are you so expensive? Hello? $2. $2! That's crazy. The shipping estimate's $23. What joy. Global Standard Direct. 8 to 13 business days. Lock in. Okay. I think this is something that we're just gonna have to figure out. Let's see if the NRF54L15 has a QFN 48 footprint and if it includes what we need. Because here's the other thing, is that this is still something that I need to figure out in terms of my design. The simplest design that I could do is just to use a button cell battery and power the NRF54L15 off of that button cell. which would work. There's a lot of designs that do this, and it's really simple in terms of the components that you need to buy. Or you could add the complementary NPM 1300 or 1100 on there, and that would allow you to have lithium-ion rechargeable battery with USB as well. Because the button cell, I don't think you can... I guess you could technically just integrate USB without actually powering it. Nordic use USB when powered by battery. NPM, yeah. Node package manager, node package manager. No, this is the NPM. Oh, 1304. Is this something new? How new is this?
Hey, I'm Robin from Nordic, and this
2 years ago. Okay, so this is not that new. Whoa, what is this? NR54 LM20A, 66 GPIOs, high-speed USB 2 megabytes NVM, non-volatile memory, 512 kilobytes of RAM. Node version manager. There's too many N's. There's too many V's. There's too many P's. There's too many M's. Yeah. Let's see. Read more. 54L15. This guy. 1304. What's the difference between 1304 and 1300? I'm a little confused. Power management IC overview. Okay, 1304, 2 buck regulators, battery charger, 2 LDOs, load switch, termination voltage 3.5 to 4.5. Minimum charging current is 4 milliamps versus max charging current is 100 milliamps. Okay, so this is really just for much smaller batteries, I think. Type C, 200 milliamps. Yeah, okay. You know what? This only comes in QFN as well as WLCSP. I'm definitely not going to go for this guy because I don't want to increase the board cost. But I believe the QFN should be able to be used with a 2-layer board. Now that is going to mean that doing signal integrity on a 2-layer board is going to be a pain. But should be doable. Should be doable. Okay, yeah, 2 megabytes of non-volatile memory. Zigbee thread, Bluetooth mesh. Bluetooth mesh. QFN 52. I thought it was a QFN 48. Oh, I guess it's a 52. Yeah, no, it looks like it. All right, let's take a look at the documentation and then see if there's any hardware and layout, reference circuitry. Let's see. For PCB reference layouts, go to Nordic. Yeah, that helps a lot. Thanks. Oh, there it is. Reference layout. I'm just blind. My fault. First published version, save. Let's unpack this. Extract all. Go inside your Altium Designer. PCB project. Open this in Altium. Let's see what they got going on here. So this is a 4-layer. And this is what they recommend. Wow, this is beautiful. If I open up the schematic, ooh, this comes with the antenna. Place matching network as close as possible to the IC. Wait. Where? So the output of C11, oops, that's the wrong one. The output of C11 should go to RF. Polygon cutout. Okay, so they want to do a 4-layer board here. I mean, I could just eat the $7 plus 100% tariff. Thanks, Trump. It's not a big deal to go for 4-layer over 2-layer if it makes my life easier, I think. Especially considering I get all of these pins just broken out for free, basically. Saves on design significantly. Okay, cool. Then I know exactly what we're building. Very nice. Alrighty, so now that I know this layout, let's take the keyboard layout and then paste it into Miro. Is there a way to export this? Properties, customs, download. You know, I'm just take a screenshot. Actually, before I do that, let's go through and label these. It's going to be A, properties, top legend, A. Oh wow, you can do multiple legends. Hello. S T F G C X C E Q W E R T. This is B. Then this one's going to be Control Super Alt Space. Boom, boom. Alrighty. This is going to be Okay, this is going to be interesting. H. No, this should be Y. U. N. J. M. I. K. Dot. P. Semicolon. And this is gonna be... Oh shoot, I'm forgetting a comma here. Comma. Dot. It's gonna be /. This is going to be apostrophe. What is this gonna be? What do I want that to be? Oh, that should be O. I'm stupid. So this should be O. This should be P. I was wondering why it didn't match up. Okay, cool. This should probably be Shift. This should be backspace. This should be, what should this be? Enter. And then oh, I don't have enough layers. Maybe no. Maybe this should be Shift. Actually, just do Control Alt Shift. Oh, cancel. Thank God. And then do this guy should be Layer Shift. Let's call this function. And I can always designate these as dedicated function keys if I realize that I need them. Okay. This is a god-awful keyboard layout in terms of usability, but we're going to jump off the deep end anyways. Copy, paste this in the Miro. Where did it paste? There we go. What joy. I wonder if I can import SVGs into Miro. Surely, right? Like, that's the whole point of this platform. Open. A really god-awful layout? Well, this is like already pretty bad. Like Glarsis video level, no, I can't do, bro. Glarsis literally has like an entire team of patrons, me included, that fund his cabal of bad keyboard decision makers. Like, there's no way that I can compete with that. Hey, it does work. Beautiful. Let's call this layout. Can I add a caption? No. Board with the switches upside down? Oh, that's already been done before. That's actually done very, very frequently on, what's it called? Oh, flipped over. So you type upside down. Not the weirdest idea. Yeah, definitely not the weirdest idea. I could probably make that. In fact, if I make a wireless split keyboard, it kind of lends itself automatically to being used upside down. I cannot lie. or vertically at least. I mean, that's just like 180-degree tinting. Like screw 90, we're going all the way. So plate builder. Okay. Cool. Well, now that we know that this is going to be this, what we can do is actually just start importing all of the components and all that jazz into the projects. And this should be relatively simple to do because bill of materials, no, layout PDF files. Where is this getting its component from? What I was thinking is I can just take all the components that are on here on this recommended layout. Let's see, where is it getting this? Altium lib, dblib. Where is this? Hello? Oh, that's an Excel file. I'm stupid. Close Excel. Where is this getting this from? Oh, well, it's okay. I can just remake it myself, I guess. They probably have the NRF 54L15 somewhere in here. Okay, so what we're gonna do is go to manufacturer's price search. Actually, let's search in components first. NRF 54L15. Nope, no dice. NRF 54L15. Are you in here? No, you are not. Why are you not in here? How do I add you in there? Like... show? Altium lib, dblib, database library. How do I add this to my project? Classification confidential. Oh yeah, we forgot to update the confidentiality before releasing it. Guys, why is this like the most difficult thing that I've done so far? Where... Can I make a duplicate of this component? Well, that's half of PCB design, is just not knowing what's going on. TBH. Oh, yeah. Component not found in libraries. That's really cool, by the way. I guess they just exported it. I don't want to make my own footprint though, man. This is so tragic. What if I just copied and pasted this thing? Copy. Paste. Hey, I can. What the hell? Can I look at database libraries? Components, messages, navigators, outputs, PCB design properties. Storage manager? It's storage manager. Oh, is this simulation generic components? Search all. No? Hmm. What am I even... Okay, I mean, I guess the easiest way to go about this is probably to just import this into the project. Just copy paste this, plop it right in there along with the layout. And then I just have to figure out my own RF antenna design. Or I could solder a chip antenna. One or the other. Matching network as close to the IC. Okay, so if I just copy this and just paste it. How are these named? 1, 2, 3. Paste. C1. This should be L1. That's pretty funny. See if there's a way. Paste this designator. Control Shift V. Yeah, I guess I could just add both of these to the project itself. What's on the bottom layer? Is there anything on the bottom layer? Control F. There's nothing on the bottom layer, it's just a bunch of VIAs. So realistically speaking, if I can just get a little bit, what's the board size? 15 by 13 millimeters square, which I definitely have that. Just in area somewhere. There's got to be that somewhere. Okay, I'll just add these two to my project then. Add existing to project. Downloads. Reference layout. Altium Designer files. These two open. Boom! Alright, cool. Now we're just gonna close project. Save. Oh, I didn't want to save that. Whoops. All good. But these are shortcuts. Your project folder. Alrighty, so what I gotta do is go over here. Boom, boom. Okay. Then we're going to go here and then add existing to project. And then this is going to be where we go to. Over here, split keyboard PCB, grab this, grab, paste. These two, open. Yay! Now we got these two PCBs going. Embed. Embed PCB in another PCB. Because I don't want a multi-board assembly. I just want one PCB with multiple boards contained within them. So I think what I can do is just save this to server. Cool, we're chilling. PCB1. All right, low-key, we're gonna worry about this later. For now, I think what I want to do is get started on doing the layout because I think that's gonna dictate how we do the rest of our design. So, what I want to do is go to components, place the MX switch footprint, Cherry MX switch that I made. In fact, how many of these do I want to place is the question. Where was our keyboard layout? I should probably copy this also. What if I just keep this in Miro? This is so cursed. You know what? If it works, it works. Layouts, JSON. Cool. Keyboard layout editor. And then I want to, what was I looking for? Checking how many keys we have in total. In total we have 38, so that's 19 per. So for now I'll start with 19. 2, 3. It's actually 3 per. I'll space these out a bit more if I need to. Right now this looks good though. And then I'll split this up a bit actually. 2, 3, 4. All right, cool. So that's gonna be this. Now, let me think. The interesting thing, can I make this? So what I'm thinking is, can I make this mirrorable? Because it would be really cool if I could mirror this layout. I mean, the easiest way to do that would just be to do this. And then this would be really, you could design a PCB that would basically just be the same thing on both sides. But what's the fun in that? I mean, let's try to use our noggins a little bit. Because if you wanted to flip it over, you could just make it double-sided. Have one side have the microcontroller on the top of this, have the other side have the microcontroller on the bottom of this. Would that be possible though? Because you could just have the microcontroller be on the same side regardless. Everything else would be on the same side. Is it actually possible? I'm not sure. I think it should be. Which means that I can just get rid of these switches. We can just do one design, which is pretty cool. But let's come back over here, redefine the board. Because what is this? Redefine the board shape. Set snap grid to be 100 mil. Boom. Can I set the units to be something other than mils? Altium view toggle units Q. There we go. What did I want to do? Design, redefine board shape, edit board shape. What is going on? Design. Oh yeah, what is this white thing? Altium PCB view white square. That's the sheet. Sheet line area color. This is a layer stack. Sheet line. Where is sheet line area color? Oh, I see it. I'm blind. Okay, cool. So, for now, what we can do is actually lay out the PCB itself. So what that's gonna look like is, first and foremost, oops, import changes. Error occurred in the compilation. Yeah, that's fine for now. Yeah, that's fine for now. Validate changes, footprint not found. Oh man, footprint not found. Let's actually go over here and change this really quick. Let's auto number these. Tools, annotation, annotate schematics, across then down. Reset all. Update changes list. Accept changes, validate, execute, close, close, save, PCB1, design, import changes, execute, close, 3, 2. Alrighty. So, we got our little switches here. Joyous occasion, these switches. The question is, how do I get the spacing correct? Because really, this is going to be slightly annoying. Let me just grab on. Here, set this to millimeters, 15.6. That's the size of a switch itself. Hmm. Nineteen 19.05 millimeters. All keycaps for Cherry MX are made for that spacing. Schematics, that's them doing the little switches. Alright, they got these. Okay. So I should probably edit the switch footprint to have the 19mm spacing that I need as a designator. It doesn't have to be. First of all, can I hide this room? Because this room is kind of annoying me, I can't lie. I can just make it larger. That works, I guess. $19mm. So what I have to do is just go over this, component actions, PCB libraries, show in server, and then edit this, edit. That'll pop up with the thing. And now what I do is I go to the footprint. And then I need to go draw a box. All right, we're gonna do a line. Gonna do a line in mechanical 1. It's gonna start here and go up. 19 would be 9.5, right? I think something like that. 9.5. Does this make sense? This is like 15.6, 16, 16.5, 17.5. Doesn't make sense. What is going on? Why does it not line up? Okay, so now the distance from here to here. Switch this to millimeters, 19.0, perfect. And the distance from here. Wow, what the heck? Okay, well, I'll just trust that it's correct. We're gonna make the width a bit smaller, 0.254. Actually, having it be this wide is probably fine. If I wanted to, I could probably just do 2. What is it? 127. Yeah, that works. All right, cool. So we have a switch. We do indeed have a switch. We're just gonna save this. Close. This needs to be updated. Save this to server. Update switch with 19 spacing. And then that goes in there, and then I can update all of these components. Component actions, update selecting components, update all footprints, execute. Okay, close. And now these should theoretically tools. Yes, no, maybe so. Hmm. Why is it not updating the thing? Man, did that not work? Component actions, show and server. Pull this up. Let me see the 2D footprint. It didn't save. No, why didn't it save? That's so weird. Edit. Edit. Wait, why didn't it save? That's so odd. Well, all good. Let's just remake it really quickly. See how fast I can speedrun this. Well, let me switch this to the correct layer. Because I want this. Actually, let's just delete this top overlay. And then just place another one for the actual 9.5mm spacing that we want. Oh. I said hit update to latest. Is that really it? Alright, fair enough. Okay, so now if I update this from selecting components from libraries, accept changes, close all the documents, wait, cancel, close comparison report. Because there should be a mechanical layer difference. I don't know if that can pick it up though. What is mechanical layer 13 anyways? assembly. And 3D body is M4, bottom is M5. M14, M11, M12. Glue points are M9, solder paste, overlay. M1 is bored. Oh. Okay, that's why it doesn't want to do that. I should re-update that then. Man, for the third time in a row, we are changing this guy once again. Edit. Close. Update. This needs to be set to a different layer. Which layer should I do? Probably makes sense just to do top overlay. That's a little messy because we also have this one. So I could just remove this guy. Okay, so we can probably just go with this. Back to where we started. Close. Oops. Close. 2D. Perfect. Now we are going to save this. Save to server. Release. Okay. Still nothing. What the hell? There we go. Alright, perfect. So now, this is where the fun begins. Because we can set grid properties. We can set this to be, what's 19 divided by 4? 4.75 millimeter snap grid. And this guy itself should also be aligned. Alright, so we want to start from the top. Which one? Let's just place a smack dab in the center. And then how does this go? Let's pull up keyboard layout editor on the side monitor. Let's put this. Can I tile this? Tile. Split vertical. There we go. So this guy, switch 1. I should have not auto-named them. That was stupid of me, but it's okay. Switch 2. This guy goes here. Switch 3. Where did switch 3 go? What? Oh, okay. Switch 3 goes here and is currently covered by the messages panel. Thank you, Altium. Switch 4 goes in the middle, over here, and then... Oh, it's covered by the designator. Yeah, that's fine. That's actually okay. Because we're going to be hiding this anyways, probably eventually. Are we? No, it's going to go somewhere else. Can I move this to be like right here for all of the switches? That would be really helpful. Switch 5, switch 6. Actually, switch 6 goes over here. Halfway down. Switch 5 goes over here. Quarter of the way down. Switch 7 goes over here. Switch 8 goes over here. Switch 9 goes here. Switch 10 goes here. Switch 11 here. Switch 12 goes here. Switch 13. Switch 14. Switch 15. And then we get switch 18. Switch 16, 17, 18, 19, which I'll go down there. Which this is where it gets kind of interesting. I think easiest to do is going to be start out with switch 16. Oops, I'm moving the entire room. Start out with switch 16. Place this. Where is the center of this one compared to this? So it's shifted a quarter. I got that. Down a half. And another third, like this. All right. So this is our layout. Let's switch the snap grid back to 1 mil, or 1 millimeter, I should say. So I can see how large this room actually is. Then we can actually redefine the board shape. To just be this. What the hell is happening here? There we go. Okay, what's the size? Horizontal 101 millimeters. Vertical is 100. And I can reduce that just by a little. If I go over there and just squish this to the side. So let's redefine. And even then, we shouldn't necessarily be pushing it all the way to the edge like this. It's not very good design practice anyways. So what I'm going to do is actually just remove this 19mm silkscreen, just so that it also looks a little cleaner later on. But at least for what we're doing right now, this helps us get everything placed, so that's what I'm going to do. Now all of this should move alongside. So yeah, this is really reminiscent of the mitosis layout, mitosis keyboard layout. Oh, I wonder if this would go crazy actually. If I just take these and then rotate it. Oh, other way. Oh, because it stays in position. Man. Well, for now this is fine. Then we can redefine the board size once again. Design. Board shape. Oh no, I need to go to this, design, redefine board shape. Actually no, design, edit board shape. This is going to be easier to just do the 1 mil change really quick. Right? Maybe? Let's do 1mm. There we go. Cool. Now we have a 100 by 100 board. Awesome. And if we go to 3D view, it's like we're like halfway there already. Look at that. Isn't that beautiful? Now the next step is going to be figuring out an area that I can slap the microcontroller on, and then potentially also using some of the space down there to add some other tidbits if I want to. Although for now I just want to keep this as simple as possible, perhaps, so we shall see. I also need to see if I can just make this reversible as well. guess I could just have one side have the microcontroller on top and one side have it on the bottom. Like, it shouldn't make that big of a difference. Really, the biggest difference is where the connectors are, and I should be able to easily place 2 different locations for the connectors when it comes to like batteries and USB. So that shouldn't be too big of a deal. And even then, I could just have a mid-mounted USB port. Yeah. Okay, well, I think this is a pretty good stopping point for now. Let me save this and save this as well. Make sure we keep our progress here. Save this to server. Okay. And really, I think this is pretty good. Let's document the progress so far and figure out what we need to do. So, this is done. I have not gotten Zephyr set up yet. Schematic is started. Need to connect switches to MCU. I need to finish the layout. MCU plus antenna plus PMIC. I need to get all library components figured out next stream. I think this is the most important one. But yeah, I do like where we're at right now. We got a basic idea of what this is going to look like. Got the layout figured out, got the switches on the board in the right places. What we can do now is just lock them all actually. So let me do that really quick. Boom. First and foremost, can I just delete this room? Yeah. And then lock all of these. Perfect. Just now if I try to like move this, I shouldn't be able to. Yeah, perfect. Okay, well, for my one viewer who is still here, thank you so much for sticking around. Hopefully this was somewhat entertaining. But I will continue this work tomorrow. Hopefully tomorrow we'll be able to make some very good progress. Oh, it's you, Ben. Let's go. So I'm going to keep working on this, and goal will probably honestly be to order the PCB by the end of the week and then switch gears to a different project while we wait for them to make it in 8 to 13 business days. 1K subs in a month, there's no way. But it doesn't matter, because really I'm just doing this just to keep myself accountable. It's actually a miracle how productive I'm being just by like actually working. It's the craziest thing. I spend all my time just reading through data sheets and like not actually doing anything, that when I actually start doing stuff, I just know how to do it. Isn't that nice? So the thing is, for the layout, a couple of things. Maybe I'll just make 2 separate areas for the MCU, or I'll just have a single MCU. Yeah, probably just single MCU really. And just have it be reversible. Have the connector be reversible. And that'll be enough. So yeah. Joyous. Alrighty then. I think I'll call it a night. and I'll see you tomorrow. Good night.